Kc and Kp for the synthesis of hydrogen iodide. This is today's lesson. In this lesson, we are going to learn equations for Kc and Kp for the synthesis of hydrogen iodide. So, let's begin. Kc and Kp for the synthesis of hydrogen iodide. Hydrogen iodide, which is gaseous in state. Hydrogen iodide is synthesized by the reaction of hydrogen gas and iodine gas. It's a kind of reversible reaction. Equilibrium that exists in the reaction is known as homogeneous equilibrium, because here all the components are in same state, gaseous state. That is why equilibrium present in the reaction is known as homogeneous equilibrium. Let us suppose here hydrogen is taken A mole, iodine is taken B mole, and the reaction is conducted in a volume which is V liter. That is, at the initial stage, time is 0. Then A mole hydrogen reacts with B mole hydrogen. At the 0 time, there is no hydrogen iodide. But at equilibrium, some amount of hydrogen converted to hydrogen iodide and some amount of iodine converted to hydrogen iodide. That amount is suppose alpha mole. Then remaining number of mole of hydrogen is A minus alpha. Remaining number of moles of hydrogen from B mole, alpha mole of iodine converted to hydrogen iodide. Then remaining number of moles of iodine is B minus alpha, and hydrogen iodide produced at equilibrium, that is alpha mole. Before all this, the reaction is balanced. Here too, then at equilibrium, 2 alpha moles hydrogen iodide is produced. Now, let us see the remaining number of moles of hydrogen is A minus alpha mole. Remaining iodine is B minus alpha mole, and hydrogen iodide produced at equilibrium, that is 2 alpha moles. Then what is the concentration of hydrogen? Concentration of hydrogen is number of moles of hydrogen A minus alpha divided by volume of the reaction, then mole per liter. Concentration of iodine is equal to, you can write, B minus alpha divided by volume of the reaction, and concentration of hydrogen iodide twice alpha divided by volume. This is mole per liter. Now we got concentrations of hydrogen, iodine and hydrogen iodide. Then Kc is equal to, we can write according to law of mass action, concentration of hydrogen iodide. Here coefficient of hydrogen iodide is 2. This 2 will be as power. divided by concentration of hydrogen into concentration of iodine. This equal to, we can write twice alpha by volume square divided by concentration of hydrogen, A minus alpha by V into B minus alpha by V. From this we can write 4 alpha square by V square into V square by A minus alpha into B minus alpha. This is we obtained putting the values of concentrations of hydrogen iodine and hydrogen iodide. Let us proceed. Kc is equal to, we got this one. Now Kc is equal to V square V square. We get 4 alpha square divided by A minus alpha into B minus alpha. This is for Kc. In this reaction, hydrogen, iodine, 2 hydrogen iodide, number of moles of reactants 2, number of moles of product 2. So delta N is equal to 0 here. We know Kp is equal to Kc RT delta N. Kc RT delta N 0. Then we can write Kc, because here RT to the power 0 is equal to 1. So Kp is equal to Kc for this reaction. We know Kc is equal to this, then Kp will be same value, that is 4 alpha square divided by A minus alpha into B minus alpha. This is Kp, Kc, and this is Kp, same value. We see here that Kc and Kp are not related to volume and pressure. That is, here no term of volume and pressure in these equations. That is why Kc and Kp are not dependent on volume and pressure. Kc and Kp will not be changed even if volume and pressure are changed. This is significance of Kc and Kp. Number today, thank you very much.